Hey guys, Jake here, coming at you with another math lesson today. Today I'm going to be showing you how to find the integral of even functions, and I'm going to be showing you how to do that with this integral right here, the integral from -6 to +6 of x to the fourth plus 16 dx. So the reason I'm showing you this is actually one of the formulas on my Calculus 2 study guide. There's a link down in the description so you can go check that out, and I highly recommend you go grab that. It's available for instant download so you can start using it today, but that'll make homework and studying for exams a lot easier for you if you're taking an integral calculus class, so go check that out. But one of the sections on that study guide talks about finding the integral of symmetric functions, which basically just means finding the integral of odd and even functions. And so I'm going to use this example to show you how to find the integral of even functions. So the first thing that you want to consider, there are a couple requirements that need to be met before we can use this nice little trick, which are, first of all, our function that we're integrating, so x to the fourth plus 16, needs to be continuous over the interval that we're integrating it on. So in this case, we need to make sure that this function is continuous on the interval of -6 to +6. And this function here, x to the fourth plus 16, is a polynomial, which means it's going to be continuous everywhere. So I'm not going to show you how to prove that, but we do know that this function is going to be continuous on this interval. The other thing that we want to show is to basically confirm that this actually is an even function. So what it means for a function to be an even function is that we need f of -x to equal f of x. So if we can show that this is true for this function that we have here, then we know that it's an even function, and then we know we can use this little trick, which will make integrating it a bit easier for us. So let's just kind of figure out what these two pieces are. First of all, f of -x basically just means going to your function f and replacing all the x's with a -x. So that would just give us -x all raised up to the fourth power. And make sure you put the negative sign in the parentheses there, plus 16. And then f of x is just going to be whatever this function is. So x to the fourth plus 16. Then if we were to simplify this, -x to the fourth power is just going to be x to the fourth power. Those are going to be the same because the even power cancels out the negative essentially. And then plus 16 equals x to the fourth plus 16. So we can see that this is an even function because these two things are equal. They're exactly the same. So we know that this is an even function. We know it's continuous on the interval that we have, that we're integrating over. So we know that we can use this little trick. So this little trick tells us if we are integrating an even function from, the negative version of some number to the positive version of that same number, so -a to a, in this case -6 to 6, of some even function f of x with respect to x, we can rewrite this as the integral from 0 to a. So now we don't have to worry about this negative lower bound here. It'll just be 0, which, sometimes may give you a little bit easier integral to evaluate of our function f of x. But then what we need to do is double that. So it's just going to be 2 times the integral from 0 to a instead of the integral from -a to a. So what we can do then is we can rewrite this original integral as the 2 times the integral from 0 to 6 of x to the fourth plus 16 dx. Which, that's not really going to make the actual integrating easier, but it will make evaluating that integral a little bit easier for us. So to integrate this, all we would have to do is use the power rule. So we can, raise our power by 1. So let's actually just go ahead and take that down here. 2 times the integral from 0 to 6 of x to the fourth plus 16 dx. So we can do this using the power rule. We'll raise our power by 1, which makes it x to the fifth, and then we'll divide by that new power. And then the integral of 16 is going to be 16x. Then we're going to integrate this, or evaluate this from 0 to 6. And then remember, based on our formula, we then have to double that result. So evaluating this from 0 to 6 essentially just means, plugging in 6 into this function for x, and then plugging in 0 into this function for x, and then subtracting them. So when we plug in 6, we're going to get 6 to the fifth power divided by 5, 1555.2, and then we have to do 16 times 6, which is 96. So this is what we get when we plug in 6 into our function. Now what we have to do is plug in 0 and subtract that. So plugging in 0, we're actually going to get 0 to the fifth, which is 0, divided by 5 is still 0, plus 16 times 0. So when we plug in 0 into this, we just get 0. So that's why this little trick is nice, because having 0 as our lower bound, sometimes that makes, a lot of times actually, that's going to end up making this a lot easier to evaluate, because subtracting out 0 is, much simpler than what we would get if we plugged in -6 into this. So when we kind of simplify this down, that's just going to give us 2 times 1651.2, which is 3302.4. So that's it. Hopefully you found this video helpful. Go check out my Calc 2 study guide. The link is down in the description. You can go download that right away and start using it today. Thanks, and see you next time.